begin with, we need to introduce a few concepts. The first is sigma notation. So example 1, write in sigma notation and evaluate the sum of the terms 3 to the I for I equals 1, 2, 3, 4, and 5. Well, the sigma indicates a sum. The sum from I equals 1 through 5 of the terms 3 to the I. That means we have 3 to the 1, plus 3 to the 2, plus 3 to the 3rd, 3 to the 4th, plus 3 to the 5th. So sigma notation is just a much more compact way of writing this. And that would be 3, 9, 27, 81, and 243. If we sum those, we get 363. Part B, write the sum in sigma notation 1, 1/4, 1/9, 1/16, and 1/25. We want to sum those. So I equals 1 is generally our starting point. You can start anywhere, but generally we want to start at 1. Okay, well, if this is the first term, there's our second term. I'm just going to write these here. 1, 2, 3, 4, and 5. So we're going to go to from I equals 1 to 5. And what it looks like is happening is this is 2 squared, this is 3 squared, 4 squared, and 5 squared. So it looks like we have I squared in our denominator. I squared, and it's 1 over I squared. Now notice I is a dummy variable, okay? The letter I actually never comes up in our sum itself, kind of like in part A. We just end up with a number. So saying I squared there just means we're changing the value of I from 1 to 2 to 3 to 4 and all the way to 5. And it increments by 1, of course, counting in natural numbers. All right, to evaluate some of the sums that we're going to have, we have these 4 facts. Okay, if you are summing up a constant, it is equal to the constant times n, the upper limit there. If you're summing up I, then it is n times n plus 1 over 2, where n is our end point there. I squared n times n plus 1 times 2n plus 1 over 6. And then if you're summing up I cubed, n squared times n plus 1 squared over 4. Again, depending on the value of n. So we're going to need this a whole lot on this next one. The sum of the terms I minus 3 cubed for I equals 1, 2, 3, all the way to 200. So this is starting at I equals 1, going to 200 of I minus 3 squared. Okay, so I equals 1 to 200. That would be I squared minus 6i plus 9. And I'm going to break this up into 3 summations. Break that into I squared minus 6 times I equals 1 to 200 I plus I equals 1 to 200 of 9. Break that into 3 different summations. Well, the first, the I squared, is going to be n, which is 200, times n plus 1, 201, times 2n plus 1, which will be 401, divided by 6, minus 6 times the sum of I, which is going to be based on that formula, n, so 200 times 201, that's n plus 1, over 2, plus 9 times 200, because when we're summing up a constant, it's the constant times n. So in this case, it's going to be 9 times 200. All right, and that total is 2,567,900. Let's do something very similar for part B. the sum of the terms I cubed minus I squared for I equals 1 through 6. So I cubed minus I squared, I equals 1 to 6. All right, well, that will be equals 1 to 6 of I cubed, I equals 1 to 6 of I squared, and I cubed is going to be 6 squared. That'll be 6 squared times 7 squared, n and n plus 1, over 4, minus, for I squared, we have n plus 1, 2n plus 1, which would be 13, over 6, and that total is 350. Next, find the value of the sums, or find the sum of the values f of x equals x cubed over the integers 1 through 10. That is equivalent to asking the sum of I from 1 to 10 of I cubed, which based on our formula is 10, that is our n squared, so 10 squared, n plus 1 would be 11, so 11 squared over 4, which is 3025.